So today we're going to be talking about programming continuous rotational servo motors in CircuitPython. I've got my microcontroller here. I'm using the Metro M4 Airlift Lite Express. First, how do you know if you have a rotational servo? Because most servos are positional, and they'll look like this. For easier use, I have 3D printed a little adapter here that allows you to connect LEGO Technic parts to it. So it's a LEGO Technic compatible adapter that will allow me to basically display this a little easier. So this is a standard servo with a servo horn here, but I have simply glued on a little adapter here to be able to connect that part to the horn. So if I've got a positional servo, I should be able to rotate this horn, and at a certain point it's going to stop because it's not actually going to allow me to go any further. If I have a rotational servo, I should be able to just continuously spin this servo around and around and around and around and around forever. So let's talk about how do you actually make one of these rotational servos run. A servo has 3 signal pins connected to it. White is a signal pin, red is your power, and black is your ground. Typically, servos take a 5-volt power source. Some will take 6 volts, some will take 7.4 volts. It just depends on your specific servo, so just check your data sheet. For this video, I'm using the FiTech FS5103B is the positional servo variant, R is the rotational servo variant. To wire one of these, really simple. I'm going to take a Servo Shroud to male jumper cables, be able to connect them in. Now this does mean that I am going to be providing power from my microcontroller. If you're going to be using something more than one servo, you definitely want to use an alternative power source and tie that ground back to your microcontroller. I'll talk more about how to do that in a future video. So for here, I can connect it to any digital pin of my signal, digital 0 to 13, and I'm just going to connect to 5 volt and to ground. You can also connect to any analog pin, and when I say any, most pins on these boards will allow for a PWM or a servo or motor object to be attached to them. Not all of them will. Sometimes you'll get a serial output that says pin, all timers for this pin are already in use. That means that that pin does not accept a PWM object. So you cannot provide a servo. If that's to happen, just choose another port to drive from. So I'm going to choose D0 in that case. And now let's head on over to the computer. So back to the computer here, the first thing I'm going to do is I'm going to import time. I'm going to import board. We're going to import PWM IO for pulse width modulation in out. And then I'm also going to say from Adafruit _motor import servo. There are 2 ways to control servos with CircuitPython. You can control it via high-level control using a library, or low-level control by actually sending pulses. It's way easier to control it from a high-level control, but you can do it low-level. In order for this one to work, you have to make sure on your CircuitPython lib folder that you have the Adafruit motor library installed. And that'll have motor, servo, and stepper inside of it as a folder. I'll put the link down in the description below for where you can find that. Once we've imported our libraries, we need to actually init our servo. So in here, the first thing I'm going to do is I make a PWM object. So I will say PWM equals pulse width modulation in out dot PWM out, and it says board.d0, and our frequency is equal to 50. Now, occasionally you might find that your servo starts doing some weird things when you pull this in. Some servos might have a frequency of 60. Most of them are 50. If you're getting weird things, you can try change your frequency. If you get weird things as well, you might need to change your duty cycle. Most of them will just accept the default though, so you probably don't need to change this at all. But if you do find you're getting some weird, some weird behavior, check your servo's data sheet for that. Once we made a PWM object, we need to actually also create our servo object. So I'm going to say servo_1 is equal to servo.continuous servo with PWM inside of our brackets. So this is going to create a continuous servo object. Do not just put in a servo object, because that is going to initialize a positional servo. In this case, we want a continuous. So let's actually make this thing drive around in a while true loop. So first I'm going to print forward, and I'm going to say servo_1.throttle is equal to 1.0. You can give any value between -1.0 all the way up to 1.0. 1.0 is max forward, 0 is stop, -1.0 is max backwards. So let's do a time.sleep for 1.5 seconds, and then we'll say print stop, and we'll say servo_1.throttle is equal to 0.0, time.sleep for 1.5 seconds, and then we will print reverse, and we'll say servo1.throttle is equal to -1.0, and we'll do another time.sleep for 1.5 seconds. So if I did this correctly, if we save this over, it should pop up. Oh, I spelled continuous wrong. Continuous. Let's try that again. There we go. So now if we head over to our point and we open up our serial port, we should see it says stop. That's our max reverse, and that is our forward, stop, and reverse. So forward is going to be counterclockwise off of our servo, and reverse is going to be clockwise off of our servo. Now, this will accept any argument between -1 and 1.0. So I could say something like 0.5 for half speed. I could say -0.5 for half speed as well. So we save this, we'll notice that we're going to be running at half speed now instead of at full speed. So you could put in even something like -0.2 if you wanted to, and it will run over at 20% of its speed. You will find that 1 will not actually be max speed on this, and something like 0.7 or 0.8, depending on your servo, will actually end up being max speed. Now, let's make sure that our stop is actually stopped, because sometimes you'll find that when you run your servo, that it's not actually stopped. And I'll give you an example. So let's save this over, and right now it should just be stopped. But occasionally, you'll find that a servo will not actually be stopped. And some servos, I have electrical tape on mine just for ease of use to know what it is I'm looking at. Some servos will have a hole inside of them. And inside of this hole, let's open this up so we can actually see it in the camera, you're going to see that there will be a, let's just take this tape off for now. There is going to be a screw, and that set screw on the inside. This is why I like using the FS103, because it's got this little set screw. You can look inside there. You got a little set screw inside there. That allows us to set our stop dynamically. So if I grab a small like 00 slot screwdriver, I can slide into that point and I can rotate it until I can calibrate my stop. So if I locate it all to the right, this is actually going to calibrate your stop 0 point. So if you find that when you put in 0 and your servo is not actually stopping, you may need to calibrate your stop point. And now I actually have that stop. So you notice, like on the computer, it's still saying 0.0, but it's clearly running. So I can do my little tune, and now I have calibrated my stop. Not all servos will have these, but quite a few of them will on that continuous point. So that's it. I hope that this helped you out with being able to run continuous servos on your CircuitPy device. Let me know if you have any questions in the comments down below.